Hi everyone, welcome back to Code Eater. From this video onwards, we are going to start our new course that is on Ether.js. And in this course, we are going to learn so many different things about Ether.js, like what is Ether.js, then common terminologies that are there in Ether.js library that you need to understand so that you can be a master of Ether.js. Then we are going to talk about the different modules that Ether.js actually provide us with. We are going to then talk about the interaction with blockchain, like how we can interact with blockchain using Ether.js library. Then we will talk about interaction with the smart contract, where we are going to see how we can read and write to the smart contract using Ether.js library. And not only that, we are also going to see the difference between Web3.js library and Ether.js library and which of these library you should use in your blockchain development career. So we are going to talk about all these different things with some quizzes as well, so that and we are going to talk about all these different things with a lot of quizzes so that you can have a practice of Ether.js library. So let's start this particular course. And one important point before moving further, that I have shared all the notes related to the course in this particular slide so that you can refer it afterwards. Now let's start with the definition of Ether.js. So Ether.js, the Ether.js library aims to be a complete and compact library for interacting with the Ethereum blockchain and its ecosystem. So it is a library that is very compact in nature, and it is a complete set of library which actually helps you to connect to the Ethereum blockchain, to communicate to the Ethereum blockchain. And let us understand this with the help of an example. So let's say you have your computer, right? You have your computer which you have converted into node, okay? And now you want to talk to this blockchain network that you are seeing on your screen, right? On the right hand side. So your computer, which actually wants to talk, and definitely in this case, we will say it as a node, right? Because we have talked about node and computer and all those terminologies in the blockchain course. If you haven't watched that, please do watch that particular course. So let's say this particular computer or node wants to interact with this blockchain network. So how this communication will take place? Because this computer that you are seeing on your left hand side is something which belongs to the I will say to this real world part, and this blockchain actually belongs to this blockchain world part. So how we are going to make this connection between these two different worlds? We need a bridge so that we can connect these two different worlds, and that bridge is Ether.js library. Like Ether.js library, we have other alternative as well, like we have Web3.js as well as Web3.py. But Ether.js, as I said, is one of the libraries which can actually help you in a lot of different ways as a blockchain developer. So here, if you will see, Ether.js library is actually acting as a bridge between your computer and this blockchain. So let's say you want to fetch some balance from the Ethereum blockchain. Let's say you want to know some information about any account that is already there on the blockchain, or let's say you want to interact with some smart contract that is deployed on the blockchain. You can do that with the help of Ether.js library, and which we will see practically as well. So don't worry about it. We will talk about all these things in great detail via practical in our upcoming slides. Now, before moving further and going to the practical part, we need to understand some common terminologies that are already there in the Ether.js library. So let's start with provider. Now, what is a provider? So a provider is a class which provides an abstraction for connecting to the Ethereum network. It provides read-only access to the blockchain and its status. Now, provider, as you can clearly see, it is something which actually help you for the read-only access of the blockchain. So let's say you want to read some data on the blockchain. In that case, we use this provider. Then we have this another terminology by the name of signer, and signer is also a class which usually in some way directly or indirectly has access to a private key, because we need this private key so that we can sign messages and transaction to authorize the network to charge your account Ether to perform operations. I know all this definition sounds a little bit tricky, but let me explain you it in a simple way, that you need this signer class so that you can write on the blockchain, so that you can change the state of the blockchain by signing the messages and by signing the transactions. And again, we will see this as well in the practical part. Then we have this contract. Now, what is this contract? So this contract is also an abstraction which represents a connection to a specific contract on the Ethereum network, so that application can use it like a normal JavaScript object. So let's say if you want to interact with a contract that is already deployed on the blockchain, then you need an instance of a contract, right? You need an object of that contract so that you can talk to that particular smart contract that is already deployed on the blockchain. And for that, we have this contract which actually help us in talking to the contract that is deployed on the blockchain. Again, we will talk about this in the practical way in our upcoming video. But for now, just go to this particular slide so that you have something in your mind, right, regarding all these different terminologies, so that when we are going to use these different terminologies, you can relate with all these different terminologies. Provider, something which is required to read the blockchain. Signer, which is something required to write on the blockchain to change the state of the blockchain. And contract, so that you can create an instance of a contract so that you can perform all the operation that you want to perform on that particular contract using this contract. Now, before going towards our remix ID and talking about smart contracts, let's first of all install Ether.js in our folder. So I have created this folder by the name of EtherJS course. Definitely you can name your folder as per your need. And I'm using this Visual Studio Code editor in order to create, in order to do our project. Okay. Definitely, it's up to you. Like, you can use any other code editor, but I think Visual Studio Code is one of those code editor which are most famous one and which actually provides you with a lot of flexibility. Now, what I will do is I will simply install Ether.js library inside my EtherJS course. And in order to install, I have simply written npm install -- save ethers. Now, once you will do this, you will see your node modules, and this node modules will consist of all the important dependencies, all the important libraries that we require in order to query our blockchain or in order to talk to our smart contract. Now, inside this folder, I will create a file by the name of interactionblockchain.js. And inside this, we will write a code in order to interact with a real blockchain. So let us see that. Now, since we want to interact with the blockchain, what we need to do first of all is we need to convert our normal computer into a node, because node is something which is actually the part of your blockchain network. So we have so many different nodes connected with each other and they have the copy of the blockchain, right? Now, in order to convert our normal computer into a node, into a supreme authority which can actually talk in the blockchain network, which can be the part of this blockchain network, we have two options. The first option is to install Git and to run Git, which is a very complicated option because it requires a lot of time, it requires a lot of space, energy, and so many different things, which is a very complicated way, as I said. And the second option that we have is to use APIs like Infura. So we have APIs like Infura, which actually can help us in becoming a node. So once we will install Infura to our computer will become a node. And now what we can do is we can use Ether.js library to talk to the blockchain. But the first step is to convert our normal computer to a node. So let me cross this down here. Since we have installed Infura, now our normal computer will become, not actually installed, but since we are going to use Infura, our normal computer will become a node. And now we can use this node to be the part of this blockchain network. And in order to communicate to these all different blockchains, we will require this Ether.js library. So first of all, let us go to the Infura website where we are going to use this. Now, in order to use Infura so that we can convert our normal computer to a node, we need to go to Google. We have to type Infura. Then we will have this link by the name of Infura, definitely. And you have to simply click on this. Now, once you will click on this, you will have two options. Definitely, if you have already signed up to this, then you can directly go and log into it. And if you haven't signed up, first of all, sign up and then you can log into it. So once you will do that, you will see an interface which looks something like this. Okay. And now what we are going to do is we are going to create a API key. And in order to create a new API key, we need to simply click on this create new API key. Now, once you will click on this, you will have a dialog box. Now, inside this, you have to simply select Web3 API. Okay, since we are going to talk to the Ethereum blockchain, and let me name it Ether.js. Okay, let me name this only and just click on create. Now, once you will create this, you will have an option like this. Okay, I think Infura has changed a lot. You have to simply go to this endpoints part. Now, once you will click on this endpoints, you will see a different, a lot of endpoints here. Now, once you will come to this particular endpoint, you have to simply go to this Ethereum part, since we want to connect to the Ethereum blockchain, and you have to simply copy this mainnet option. because this mainnet option will actually gives you the facility to talk to the Ethereum blockchain. So I will copy this down. Okay, and I will go back. Now inside our Visual Studio Code, first of all, what we will do is, let me zoom in a little bit. First of all, we will import our ethers library. Okay, and then we will do a require, and inside this we will import the ethers library. And after this we will have the provider, because as I told you right before only, that if you want to read the blockchain, the data on the blockchain, we need a provider. So we are going to create this provider, and to create a provider we have to simply write new dot ethers dot providers dot json rpc provider, and inside this json rpc provider just use these backticks and provide your Infura mainnet API key. Okay, I made some mistake here. Okay, sorry for that. It should not be new dot, right? Because I'm creating an object, so it should be new. Zoom out a little bit, save this. So now we have this provider, and this provider will be helpful in talking to the blockchain, in reading the blockchain. So let me show you that as well. In order to show you, I will simply console.log this provider, but I can show you this particular object. I will simply open my terminal by clicking on pressing Ctrl plus backticks. Let me clear this. And now what we will do is we will simply write node and then interaction blockchain.js, which is our file name, right? And then I will press enter. Okay, I made some mistake, I think. Okay, I think the problem is with the ethers library. So what I can see on Stack Overflow is that the latest version of Ethereum, so not Ethereum, actually ethers library is not that much stable. So we need to downgrade to this particular version. Okay, so that's why we have this particular error that cannot read properties of undefined. So what we will do is we will simply go to Stack Overflow once more, and here we will simply copy this down and we will downgrade our ethers library. Okay, and then we will check again so that not have this error. Okay, now this is done. Let me clear this out and let me try to do this once more. So I am running node, then again, okay, let me press my upper arrow key so that I can simply have my previous command, and then I will press enter, and hooray. So here we have our provider object, which you can see this is our provider object. Okay, this seems nice. And now we are going to use this provider object in order to interact with our blockchain. So what we will do is, and yes, if you're getting some error while running this node, so let me tell you that you need to install Node.js in order to run this command. Okay, and install this LTS version, because this is the one which is more stable in nature. So do not install this. Do install this and then try to run this once more. Okay, so let's go back, and now let me clear this all, and now we will use our provider in order to interact with the blockchain. So first of all, I'm going to create a function. Let me comment this out so that you can access it afterwards. We will create a function const query blockchain, and this function will be an async function. Why an async function? Because we are going to deal with promises. Okay, so we will make this an async function, and let me call this function here, because most of the time I forget to call the function and I do not get the expected output. So that's why let me call it before only. And now I'm going to use block. Okay, so what I'm trying to do here is I'm trying to get the current block number of the Ethereum blockchain. Means I'm trying to get the latest block number that has been recently created. So let me do that. Wait, okay, and provider, this we are using this, as you can clearly see, and then we are going to do get block. So this is a command which will actually help us in getting the block number. And now once we will have this particular thing, we will simply log this block number. Now we will simply run the command, previous command, node interaction blockchain.js, and if everything will work properly, we will have the current block number. So on your screen, you can clearly see that we have this current block number, that is 167,55479. But now you must be thinking that how can I trust you? It might be some mistake, or there might be some issues in your current block number. How can I trust you, right? I can understand. So let me show you the EtherScan website. And on this EtherScan website, if you will see, we have the current block number as 16755,479. So let me, okay, currently we are only seeing 77, right? So it is actually much more faster than this EtherScan. So this is great, right? EtherScan is a little bit slow currently. Let me refresh it. So we will see whether we have this current block number or not. So here you can see that. So this particular block 16755,479 has been recently created on EtherScan as well, as you can clearly see, right? If I will click on this, so this is the block that is created just some minute ago, and till that time we were writing all this code and everything. So you can clearly check from your end that okay, we have the current block number. So this is the power of ether.js. You can use ether.js in order to communicate to the blockchain, right? As I said, so this is like a bridge. So like it is like there are two persons and ether.js is a mediator. So let's say if one person is speaking French and another person is speaking English, so this ether.js is actually a bridge which is actually connecting this French person to this English person. Okay, so this is the power of ether.js, and this is one of the example that we have seen how we can use ether.js. Other things that we can do is we can fetch some balance from ether.js. Let me again control B so that we is in center. It looks much nice then. So let me comment this out, and now what I will do is I will simply create a variable by the name of balance. Then I will use await provider. Again, I'm using the provider, and I will do get balance, and I will provide a account address which is actually on the Ethereum blockchain. Okay, like this. So we have this uh, account address, and this is a account address that is given on Ethereum blockchain, and we are going to check the balance of this particular account. You can also take your account address if it is on Ethereum blockchain, real Ethereum blockchain, because we are actually connecting to the real Ethereum blockchain, right? So you can check the balance of that particular account as well if there is an account. And what we will do is we will simply do console.log, and we can print this. So account balance like this, and then we will have the balance. And the balance that we are going to get will be actually in the form of a big number object. So it will be in the form of a big number object. Big number object, we demonstrate this with bn. What is this? I'm explaining you. Let me first of all run this particular thing so that I can show you. So here, if you will see, we have the account balance of this particular account address, which is actually in big number object. And big number object is actually a concept of JavaScript, which you can refer if you want to learn in more depth. But let me first of all convert this big number object into ether. Okay, and again for that we are going to use the provider only, not actually provider. We are going to use one of the libraries by ether.js, one of the methods provided by ether.js, which will actually help us in converting this big number object balance to ether balance. And for that we are going to use a method which is provided by ether's library, and that is utils. Now this utils will actually convert this big number balance into ether balance. And again, what we can do is we can console.log this balance as, instead of balance, we will ether balance, and this will be in. And not only that, this ether's library also provide us with a method with the help of which we can also convert ether balance into balance of way. And how we can do that? Simply again, I will copy these two things. I will paste it here. Now instead of balance ether, we will have balance in way, and instead of format ether, we will have parse ether, and this will take the balance ether. I will take this and I will paste it here, and instead of having balance ether as an output, we will have balance way, right? And let me have okay. So now let me run this once more. Let me clear the previous outputs. Let me run this. Okay, actually the thing is I need to convert, because what actually in this parse ether is not converting this to your way balance, but it is actually converting it to way balance equivalent to your big number object, which you have seen earlier as well, right? This one. So we need to convert this balance way in the form of something readable. So what we will do is we will do toString like this, and this will convert our balance back to like in the string format. Okay, so this will be a human readable kind of format, because this is not human readable, right? Let us check that. And now if you will see, so the first balance that you are seeing on your screen is in ethers, and now we have converted this ether balance into way, right? So actually what we can say is that this is not balance way. What we can say is that it is balance way bn, okay, because this is not converting directly to way, it is converting ether value to way, I will say way equivalent of binary big number object. So big number object equivalent to way, I will say like this. So now it is converting this ether to way into in a big number object, and now since this is in big number in this big number object, we need to convert it to back to way in a human readable format. So that's why we are writing this toString method, okay, which you can also do here as well if you want to. So you can directly do here as well, okay. So let me again run this so you can see the same result. Okay, I think I made a change here, right? So let me have this here. If you will see now that first value as well as the third value are the same, right? So what actually this get balance is doing is this is actually providing us with a big number object which is equivalent to your way value, and then we are converting this big number object to a string value so that we can have a human readable format of our big number object, okay. So this is how you can use Ether.js library in order to query your blockchain. There are other methods as well, which you can find on Ether.js library documentation, where you can find different methods, so many different methods in order to talk to the blockchain. We have used some, but I hope by this you will have some guidance in how to use other methods that are provided by Ether.js library, okay. So if you will go to this Ethereum basics part, if you will go to events and what you want to learn about, you can go for that particular thing, okay. And if you have this question that why Ether.js is actually providing us with the result of ethers in the form of big number object, is because Ether.js actually provides us with a lot of methods which actually help us in performing multiple operations on big number objects. So if you will see on your screen, I have shared this documentation. Definitely I will share this documentation in the description of this video. You can clearly see that big number object has a lot of operations. You can multiply, divide, do all sort of things using big number objects, and that's why Ether.js actually provides you with the result in the form of a big number object. First of all, the number is too big, which is out of the capability of JavaScript, and you can learn about big number object as I said. And second thing is that Ether.js is actually providing us with a lot of methods. You can clearly see on your screen like operations, which can actually help us in performing a lot of operations on big number objects. It's, as I said, subtraction, multiplication, addition, whatever you want to do. So that's the reason Ether.js is actually preferring big number objects. And now it's time for a quiz. So the first quiz is actually that what is an alternative of Infura? We have used Infura in order to be the part of this blockchain network, right? In order to get converted into a form of a node, right? So my question to you is, what are some other alternative of Infura? Let me know in the comment section of this video. And now we are going to talk about how we can connect to the smart contract using Ether.js library. And now you must be thinking as well that, okay, since you are going to connect with a smart contract using Ether.js library, but you haven't shown us the way how we can write on the blockchain. And don't worry, we are going to see that in this particular video. So when it comes to smart contract, we can perform two operations on smart contract. The first operation is the read one, and the second operation is the write one, right? Either we can read the smart contract or we can write on the smart contract. And when we are actually reading from the smart contract, we are actually reading from the blockchain, right? Because smart contract is deployed on the blockchain. And whenever we are performing any kind of write operation on the smart contract, we are actually writing on the blockchain because we are updating the content of smart contract. So we are actually updating the content of the blockchain, right? Now when it comes to the read of the smart contract, when we are performing a read operation on the smart contract, we require two things. The first one is provider, as we have seen, right? When we were reading the blockchain, as I said, reading the smart contract and reading the blockchain are the same thing. So when we were reading the smart contract, we require provider and Infura. And when it comes to the write operation, we require two things, that is the signer and MetaMask. And we have seen that, right? That when I shown you the common terminologies, I shown you that whenever you are actually writing on the blockchain, you require signer. And in this case, we also require MetaMask. And why do we require MetaMask? I will talk about this in our upcoming video, so don't worry about it for now. But as you can clearly see on your screen, for read, you require provider and Infura, and we have seen that as well. And we are also going to see in this particular case as well while reading the smart contract. And when it comes to write, we require two things, that is the signer and the MetaMask. Okay, but first of all, let us go to the read operation on smart contract. And now it's time to perform some operations on the smart contract. So as you can see on your screen, I have shown you this particular smart contract, and this is a very simple smart contract, a wallet smart contract. And this wallet smart contract have a lot of functions, and we are going to do we are going to perform all the function calls and everything using this particular smart contract. So on your screen, you must be seeing that we have this string, right? This variable by the name of name, which is wallet. And then we have this uint number. And first of all, we are actually setting the value of this particular num variable. And let me tell you one thing more as well, that this is just a, just a random smart contract. So I have some random functions as well in this particular smart contract. And the reason for this is very simple, because I want to demonstrate to you all the important points that you need to know whenever you are performing read or write operations on the smart contract. So do not take this as literally as a wallet smart contract. This is just a combination of some random functions as well. You can say like that as well. Okay, so that I can demonstrate you all the important points. So first of all, if you will see on your screen, we have the set value function, and above that I have written this particular comment that we are actually, like, whenever you are actually calling this particular function, that is this set value function, you are actually writing it, right? Why you are writing on it? Because you are setting the value of a state variable. As you can see, num is a state variable. Here it is. So whenever you are setting the value of num, you are actually making changes to the smart contract, you are actually making changes to the blockchain. Okay, in the same way, you have this get value function. In this case, you are performing read operation on it, because you are just reading from the state variable. Then we have this send eth contract, where you are sending some ether to this smart contract address, and we are going to deploy this smart contract to perform this particular operation. And then we have this contract balance, we have this send ether user to send some ether to a particular user and to fetch the balance of a particular address. Okay, so this is a very simple smart contract. I will share this smart contract as well with you so that you can refer it afterwards. Now what we are going to do is we are going to deploy this smart contract on GoRally test network. We are not going to deploy it on our real main network. Reason is very simple, because if we are going to deploy it on our real main network, then we need to pay a lot of amount of ether, which in the case you and me do not have. So that's why I'm going to use GoRally test network. So now let us deploy this smart contract on GoRally test network, and we are going to use GoRally test network because it is free, right? We do not have some real ether, because if you are going to deploy it on real blockchain, we need to pay huge amount of ether. Not actually huge amount, but we need to pay some amount of ether, and for that we need money. And in this case, I think I do not have any money. If you have, you can definitely deploy it on a real blockchain, but I'm going to use this GoRally test network, and you can clearly see that I have some amount of balance in it, and I have talked about all these things in the Solidity tutorial. So if you haven't watched that video, please do watch that video. Okay, and now I will deploy this smart contract. First, let me compile this, and now I will deploy this. And now in order to deploy this, first of all, I will select injected provided MetaMask so that it is deployed on the GoRally test network, which is connected via MetaMask. And now I will simply click on deploy. Okay, I will confirm. So as you can clearly see, it is asking some amount of ether. I'm clicking confirm. Let's wait for our transaction to get confirmed. Once it will get confirmed, we will see the instance of our smart contract here. Yeah, so here it is, right? So this is our deployed smart contract. And here also, if you will see, we refresh this. So it is actually it will get deployed on the GoRally test network soon, so we can wait for a while, or let's go to our smart contract instance. So if you will see on your screen, this is your smart contract address, right? We can copy this address for now so that I can use it later as well. So I will paste it here. So this is my smart contract address. And another thing that we are going to require is the ABI of this smart contract. Why we are going to use the ABI of this smart contract? So that we can make an interaction with this smart contract, because ABI act as a bridge between a third-party application and our smart contract. So that's why we need the ABI, which you can see in the compilation section. And this is the ABI. So I will just copy this down as well. I will go back to my VS Code, and in this I will create a new file, which will be, let's say, read smart contract, because for now we will perform some read operation on the smart contract. And in this, first of all, what we will do is import our ethers library. Okay, I made a mistake here, right? First of all, I need to convert this back to .js, right? Sorry for that. You must be thinking what strange thing I'm trying to do. And now what I will do is definitely I will have my provider, because we require a provider in order to interact, right? So provider new ethers dot providers dot json rpc provider, and in this we will have our API key, right? But in this case, since we have deployed our smart contract on Goreli test network, we cannot use the Infura API key of our main network, right? Because these two are different blockchain. This main network is actually a real blockchain, means talking to the real blockchain, and the smart contract that we have deployed is deployed on a fake blockchain, or I will say on a Goreli test network. So for this case, we will go back to Infura and select Ether.js, okay? And instead of selecting main network, we will select Goreli test network, right? So that we can connect to the Goreli blockchain, means Goreli test network blockchain. And I will paste it here. Okay, I made a mistake, I think, inside this. So now we have the Ether.js library, we have the provider, and now it's time to talk to our smart contract. And in order to talk to our smart contract, we need to create an instance of our smart contract. And to create an instance of our smart contract, we require two things. First thing is the address of our smart contract. So I will write wallet address. Okay. And the second thing that we require in order to create the instance of our smart contract is the ABI. So I will write ABI. And in our case, we have seen both the things. So let me go back, remix ID, and let me copy the ABI for now. And I will paste the ABI here. Okay. And then what I will do is I will go back and I will copy the contract address from here and I will paste it here. So now we have both the things, and just have this as contract address inside the double quotes. Okay. So now we have the wallet address as well as the wallet ABI. And these two things, as I said, are very much necessary in order to interact with our smart contract, in order to talk to the instance of our smart contract. So I will go down a little bit, and in this we will create a function by the name of contract read. Okay, so since we are going to read a smart contract, and this will also be a async function, and inside this, first of all, we will create the instance of our smart contract. So first of all, we will require wallet contract. So this will have the instance of our smart contract. And to create an instance of a smart contract, actually, we have to require new, then ethers. So again, we are using the ethers library like we have done here, right? New ethers. And this time we will use the contract method, you can say, okay, which we have seen in the common terminology, right, part. So this will actually help us in creating the instance of our smart contract. And in this, we will provide the wallet address, as I said, and then the wallet ABI. And we require one more thing, which I actually forgot to tell you, that is the provider, so that we can tell that what type of operation we are going to do on this particular smart contract. And provider, as I said, is for the reading of smart contract, right? Okay. So now we have this instance, and what we can do is we can call this smart contract and we can check the instance of our smart contract is ready or not. For that, I will simply console.log this wallet contract for you, and I will simply run this particular file. So let us run this. We will have node, then read smart contract.js, and hooray. So here, if you will see, you have the instance of your smart contract, and you can clearly see all the functions that we have actually created in our smart contract, like contract balance, get value, name, send ether contract. All these functions are present inside this instance of our smart contract, right? You can see. So this is your instance, and inside this you can see all your functions that you have created in your smart contract. And now using this particular instance, that you have created, right, you can talk to your smart contract. So we can call the functions of our smart contract using this instance. We can do all sort of operation using this instance of our smart contract, and let's do that. So let me first of all fetch the contract name. So we have given a name to our smart contract, right? So I will fetch that, and I will do that by doing await wallet contract. So we are using the instance and then dot, and then we are actually calling the name function. So if you will go back to your smart contract, we have this name variable, right? And since this name variable is a public variable, we know that for a state variable which is public in nature, a getter function is all like automatically get created by Solidity, right? So we can call this name function as a getter function, and we can fetch the name of our smart contract, and we can check that as well. Console.log and then contract name like this. Okay, let me run this for you so that you can check as well. So here you can see that it has returned us with this wallet, right? Because this is present here, wallet. In the same way, what we can do is we can do other sort of operations as well. Like for example, we can call the num part by doing await wallet contract using the instance again dot get value, right? Because for the num variable we have created this get value function, right? So we can call this get value function and it will return us with the num value. And initially the num value will be 0. Why? Because we are not initializing this num variable with anything, so initially it will be 0 as it is an integer data type. So if we will check the value of this again, console.log num, you can check that as well. I'm again doing this, running this. So it is taking some time. Okay, so it has returned the value in the form of a big number object, and you know how to convert this to a string, right? So there are two ways to convert this to a string. So the first way is directly to do string num. Okay, I will again do this, and you can clearly see that it is returning us with 0. And I think the another way is to directly do this, right? Like we have done in the earlier case. Let me try that as well. String, let's do this again. Check. Okay, okay, in the previous case what we have done, two string. Okay, sorry for that, we use two string. Let me, here again you can see that, right? So you can perform any of these two operations in order to get the real value, the value in string form, to convert your big number object into a string, right? Let me comment this out. Now another thing that we can do is we can fetch the contract balance. Now to fetch the contract balance, I want you to comment down the result. Like I want you to do that before me. Okay, pause me for a second and try by yourself, and then we will match the results. So I hope you have tried by yourself, and now let's try together. First of all, we will do await, right? Again the instance, and then contract balance. So we are actually fetching the balance of our smart contract. And again, since the balance will be in the form of way and in the way object, so we need to convert this balance at contract dot utils dot format ether, and inside this I will provide the balance so that I can have the balance in the form of, right, not as a form of a big number object. Contract balance, and then balance contract, right? Balance at contract. And in the same way we can do other operations like const user balance. So now you know, right, how to do all sort of read operations on smart contract. So again I will do wallet contract dot account balance. Now the for account balance, what I will do is I will simply have my own account, because this account balance is for the user balance, right? Or definitely any other balance you want. I will copy my address and I will paste it here, and I will paste it, right? Remember to have the Gorilla test network account only, right? Because we are talking to the Gorilla blockchain, Gorilla test network actually. So again, we need to convert this balance to eth user, and again we are going to use the ether utils dot format ether, where we will provide the user balance, and again we will console dot log this thing. So user balance and balance eth user. Okay, let's check that. Let's run this. Hope it will work. So contract balance is 0, definitely, because we haven't provided any balance to the smart contract. And this is my balance, which is actually given in I'm saying this is given in ethers, so it is 0.1988, and we can check this, so it is 0.1988, right? So here you can see that how we can perform read operations on the smart contract, and that too is very easy. As you can see on your screen, you have to simply create an instance. This is the first step, and to create an instance you require three things, not two things. In the starting I told you misinformation, I will say. So we require three things: wallet address, wallet API, and provider to perform read operations. So this will actually help you in read operations only. And then what we can do is we can perform all the read operations that we want. And whenever we are reading the smart contract, we are actually reading the blockchain. So this is very simple. Now in the next video, what we are going to do is we are going to perform write operations on the smart contract. So now it's time to see how we can actually write on blockchain, or how we can change the state of the blockchain, right? And as I said in the previous slide, that in order to change your blockchain, what you need is you need signer and metamask, right? If you want to write some operation on the smart contract or on the blockchain, what you need is signer and metamask. But the question is why do we need metamask? First of all, so we need metamask so that we can sign our transaction. So let's say, for example, if you are sending some ether to your friend, or let's say if you are doing any kind of transaction on smart contract which is actually changing the state of the blockchain. Now in that case, you need to tell to the blockchain that this is you who is doing this kind of a change. It is like whenever you are sending money to your friend, right, for via your internet banking, via using net banking. In that case, you need to provide your email ID as well as your password for that net banking, right? So that you can tell, okay, please detect some money from my bank account, right? So you are actually doing a transaction, and whenever you are doing that kind of transaction, I'm talking about the bank transaction for now so that I can relate these two things. So whenever you are doing this net banking transaction, you are actually telling the bank that, okay, this is me who is doing this particular transaction, and please detect some money from my account. So that in future, if someone wants to prove that, okay, I am the one who has done this transaction, you can prove, right? In the same way, whenever you are doing any kind of transaction on the smart contract or any kind of transaction on the blockchain, in that case, you need to sign your transaction. And you need to sign this transaction, first of all, to tell that this is your transaction. And second thing, whenever you are changing the state of the blockchain, whenever you are doing some change in the smart contract, you need to pay some amount of ether. Reading the blockchain is totally free, but writing on the blockchain, writing on the smart contract actually costs you some amount of ether. So you need to tell that, okay, this is me who is doing this transaction. I'm performing this write operation, and please detect some money. So not actually money, please detect some cryptocurrency from my account. And that's why we need MetaMask. Now let's go back to our Visual Studio Code, and I will just clear my terminal for now. And what I will do is I will install React.js. Now, why React.js? I'm going to install React.js so that I can interact with my MetaMask, because MetaMask is something that is installed on the client browser, right? So in order to interact with the MetaMask, I need to have some front-end code, right? I need to have React.js so that I can interact with MetaMask. And by this way, you will also learn how to create a decentralized application using Ether.js, right? Because this will actually help you to understand how you can do how you can create a decentralized application using React.js code and using your smart contract and using your Ether.js. So this will be helpful in both the ways. So that's why we are going to use React.js, because MetaMask actually injects this window.ethereum object into your browser, and with the help of which we can talk to the MetaMask, and MetaMask actually help us in interacting with the blockchain. How? We will talk about that. But for now, let me install React.js. So npm I create React, okay, and then clear this npx create React app, okay, and I will name my folder as client. You can name it anything, but I think client is good, so I will name this client. So we have to wait for a while so that it can get installed. And I'm not going to in depth of React.js a lot of. And don't worry if you do not know about React.js, because I'm not going in depth of React.js. I'm just going to show you how you can use the React.js frontend in order to connect to your smart contract. Okay, so I'm not going to be, not going to use some complicated example. Definitely, I will create a decentralized application project after this particular video. But for now, I'm going to be a little bit simple so that you can understand the basics, you can understand the fundamentals. So now what we will do is we will go to our client folder, and in our client folder we will go to source folder, and inside this we will go to our app.js, and in this what we will do is, first of all, we will remove this, and inside this what I'm going to do is, first of all, I'm going to have my ethers library so that we can make ethers transaction, means ether.js library in order to do transactions. And I will import this ethers, and then I will import one more thing, that is React hook, that is use effect. And I will again require, or not require actually, sorry for that, I will just do import from React. And now I will simply, I can remove, no, let me have this so everything is in center. And let me remove all these things. We do not require all these things. Okay, so now we have the simple thing ready. So the first thing that we will have is, let me go to read smart contract.js. We will have this wallet address. Okay, let me have the wallet address. And another thing that we will have is this ABI, because we require this in order to create the instance of our smart, right? So just copy this down and paste it here. Okay, so now we have the ABI as well as the wallet address, like the previous case. Now since we have this use effect, and what I will do with this use effect is, I will simply create a use effect. And if you do not know about use effect, it's totally fine. You can watch what is use effect, like what use effect actually does after this particular video. But for now, I'm just using this. Okay, this. Okay, I will have dependency list as empty. Okay, now inside this use effect, what we will do is we will write our code. So the first thing that we will write is, we will create a function by the name of write contract, and again this will be an async function. And inside this async function, first of all, we will have the provider. And to create a provider, as you know, new ethers dot providers dot web free provider. Now why I'm doing this, I'm doing this so that we can connect to our MetaMask. And since I told you, right, that whenever you connect to the MetaMask actually injects this window.ethereum object, okay, inside your browser, and we are going to use that only in order to connect to the MetaMask. And then what we will do is, we will create more thing, provider.send eth request. Now what this does actually is, this actually opens your MetaMask. So you will see that. Just wait for some time. Bounce. Okay, and definitely we will have this empty. So this is syntax of MetaMask, as you can think of it as a syntax of MetaMask. And now we will have the signer, so that we can do some changes to our smart contract, right? And I told you that in order to change, in order to write, you need signer. And to get signer, what we will do is, we have already the provider, we will get the signer, this. And now it's time to create the instance of our smart contract. And to create the instance, we will again do const contract, then new, or you can like your read smart contract, you have this wallet contract, right? So let me copy this down that you do not get confused. So paste it, and then I will simply do ethers dot contract, and this time we will provide again the wallet address, wallet ABI, and then we will provide the signer. So now we have the three things ready. And now what we can do is, we can use this we can use this instance in order to make some changes to the smart contract. And how we can do that? We can simply do a wait contract, or not actually contract, I've named it to wallet using the instance. Let's say I want to call the set value function, and I want to set the value of the num variable, as let me show you this set value function. So with the help of this, I can set the value of this num variable, right? So I will simply set the value to, let's say, 100. Initially it was 0, right? We have seen that, and we will do like this. And then what we will do is, we will simply call this function like this. Okay, so I think everything is now ready, and I will simply do npm, okay, not npm start, first of all cd client, and then npm. Everything will work fine. We will have our React.js code ready. Okay, so now it is ready. Hope there are no syntax error. Okay, we have some syntax error. Okay, so the problem is that import in body of module reorder to top. So we need to just cut this down, and we need to have the import statement first, and then save it. Okay, so now we have no errors, and it is saying that, okay, this is missing some dependency, that is wallet ABI. So let me cut this for now from here. Okay, and don't worry, we are not going in depth of React, as I said, right? We will simply paste this inside use effect. Okay, so now everything is compiled successfully. Now we can go back to our browser. So now we do not have any error, and as I said, right, that eth request that we have done. So with the help of this, what we can do is, we can directly connect to our MetaMask. So we will simply do next, and we will connect. So it is connected to the account. Okay, I think let me run this once more. Okay, there is some issue. Let me check. Okay, so now we have to approve the transaction, right? So we were setting the value, set value, and since we were setting the value of our smart contract, so we are making some changes to the blockchain. So we need to pay some amount of ether. So let me confirm this. Let's wait for the set value to get confirmed and go to the blockchain explorer. And once this will be done, our value, you can clearly see that it is confirmed. And now since this is done, if we will go back to our Visual Studio Code and go back to read a smart contract, let me split this terminal, and in this we will simply again run this particular read smart contract.js. We will just let me just comment this out, and let me open this, right, and comment this, and let us check the num value. So after we have run this particular contract, means this particular client side, it must have updated the value from 0 to 100, and let us check that whether the num is updated to 100 or not. And you can clearly see here the num is updated to 100. So hooray, you have seen your first operation, how to perform a right operation on the blockchain. And remember, in order to perform the right operation, we required MetaMask. And we require, actually MetaMask is something, I will not say like MetaMask is something which is actually providing you with your private key and your account address. Okay, so that's the need of MetaMask. And another thing that you can see, that we have this signer object that we require in order to perform this operation. Now you must be thinking like, why do we have this provider and signer, two different things? I think this is done so that developers can, like we have this separation of concern kind of a thing, right, where we have two different like two different modules which are actually performing two different things. So it will be easier for developers when to use signer, when to use provider, some kind of a thing like that. Okay, and now what we can do is we can do another kind of operation. Go back, app.js. Now let us say I want to send some amount of ether to my contract. So I will comment this down, and let me go show you. So we have created this send eth contract, right, this function. Let us call this function. And how we can do that, we have to simply, okay, let me undo this, right, this we require. So what we will do is we will simply await contract wallet dot send eth contract, right? So this is the function name, and inside this we will pass an object, so that's why the curly braces, and inside this curly braces we will provide the value, the amount that we want to transfer. So in this we will have this value key, and inside this we will have the amount of ether that we want to send to the contract, and we will send this in the form of ether, right? Like definitely what we are going to do is we are going to send this in the form of ether, but this smart contract will convert this in all the form of object oriented, not object oriented, big number object and everything. So what we will do is we will use the ethers dot utils dot parse ether in order to have this amount 0.1. So we are transferring 0.1 ether to our smart contract. So let me save this, and let me check my balance for now. Let me show you my balance. So get this back, let MetaMask. So currently I have this 0.1987 ether, right? So after 0.1 deduction, I will be having only 0.0987. Let's check that. And let me now again run this. Let me stop this process for now, and let me again run this so that I can call this function once more. Definitely you do not need to do this kind of thing. This is we are doing just to understand the concept. When you will create your decentralized application, you do not have to run again and again, restart and everything. We have all the functionalities, but I will cover that in the decentralized application part. For now I'm just confirming it. Okay, we have this pending transaction. I think the pending transaction was the one when we saved the VS code and the change that we have done got into process. Let me confirm this. Okay, so it got failed because of a lot of transactions that are pending. Yeah, confirm transaction, one transaction is confirmed. And if you will see this particular transaction, so we are actually sending 0.1 eth from my account and to this contract account. Okay, so let me check that. So you can clearly see that now we have less amount of ether in my wallet. 0.1 is detected. If you will go back to VS code, and if you will check the contract address, so this is the contract address to which ether has been sent, and we can check the balance of our smart contract by doing this, right? We can uncomment this out, and let me again comment this one. and we will go back. We will run this to check the balance of our smart contract. Initially, if you remember, we have zero balance, but now if you will see, we have 0.1 ether in our smart contract. So this is the beauty of ether.js. And now let's perform the last operation, and the last operation is to send some ether to a user balance, like to a user. And I want you to try to do it by your own first of all, and let me know in the comment section. Pause me for a second and try to do it by your own. So I hope you have tried to do it by yourself. And now what we will do is we will again use await wallet track this wallet contract dot send it user, right? This was the contract name. Is so yeah, this was the contract name, and in this we need to provide the user's address at which we want to send some ether. And since this is a sending some ether, so because this is a payable function, right? So we need to also provide the balance that we want to send. So in this, what we will do is, first of all, we will provide the sender address. Let me go to my MetaMask. Let me select one address. Let me connect this. So I'm selecting this address. This is a random address. Again, I am going back and I'm providing the address here. Now again, since I want to transfer some value, and I need to do again this object, pass this object inside this again the value, and let's say I want to send, okay, simply copying this down. Okay, so it will get detected from my account, right? Because I'm transferring to this particular user, right? And the amount value is message.value, so it will get detected from my account. So let's see that. So I will see to it whether it is working or not. Let me again save this, check whether everything is correct. I think it is. Let me save this, go back, MetaMask. Okay, I need to again run this by exiting it. I'm just doing Control+C, and again running this for now. Okay, I think that why it is not. Okay, for now it is not running. Why? It was doing fine till now. Okay, but I do not have that amount of money, right, in my MetaMask, and we have seen that as well. So let me check the balance that I have. It is 0.0987. So let me transfer some 0.08 amount of money, or 0.07, right? So that we can also pay for the transaction fee. So now let me save this. Let me go back, and now you can clearly see that MetaMask is open. Let me confirm this. Confirm in my MetaMask. So 0.07 will get detected from my account, and it will be transferred to this particular. Let me see. Let's wait. And wonderful. So here the transaction is confirmed, and this account has transferred, like has been transferred with 0.07 amount of Corelli ETH, and from this account 0.07 ETH has been detected. So this is how you can actually send ether to some other person using the smart contract. So this is one of the, I will say, one of the advantages of using a smart contract, where no human intervention is required, right? You have to just run your application and everything will be done by your smart contract. So this is the beauty of smart contract. And for now, we have completed all the given functions that are given in this smart contract, right? We have performed all kind of operations, whether it is read, write, and whatever, using the using our Ether.js and MetaMask and so many different things. So hooray, congratulations. Now some people might have this particular question that, okay, since you use MetaMask in order to do the transaction in each and everything, but you haven't used Infura at this point of time, right? Because you were actually using your computer, and you told us in the previous lectures that in order to talk to the blockchain, first of all, you need to convert your computer, normal computer, into a node. But we are not seeing the use of Infura in your client side code, right? The code that I have used, like I have used React.js and have so many different things there. So the answer for this is very simple. The reason is that MetaMask is already using Infura at the backend. Yes, MetaMask is actually using Infura at the backend, and that's why we do not need to have Infura, separate Infura in my code. And let me show you that. So let me go back. Let me go to MetaMask, and let me go to this particular button. I will just click on settings. I will go to networks, and in this I will go to Go Rally Test Network. So if you will go to Go Rally Test Network, and if you will see the RPC URL, it is already using Infura at the backend. And that's why we haven't written any in app.js, we haven't used Infura here, right? Because MetaMask is already using Infura. So that's why we do not need an Infura. Okay. And that's the reason we are not using there. So now it's time to talk about the differences between Web3.js and Ether.js library. So let us see them. Now let's talk about the advantages of Ether.js library over Web3.js library. So the first advantage of Ether.js library over Web3.js library is its documentation. The documentation of Ether.js library is very simple in nature. It is well maintained. You can read from it and you will all your doubts will get clear from reading the documentation of Ether.js. While on the other hand, if you will see the documentation of Web3.js library, it is a slightly more complicated as compared to Ether.js library. Second thing about Ether.js library is that there are very few bugs. When it comes to Web3.js library, there are various amounts of bugs. So yes, again, here you can see that Ether.js is actually winning over Web3.js library. And the third one is new projects. Like most of the new projects that are coming into picture, the startups that are coming into picture, the companies that are coming into picture are using Ether.js library and not Web3.js library. Fourth point is it is well maintained. So it is well maintained by the Ether.js community. There are regular updates. Each and everything is documented. So it is a well maintained library. And the fifth one is the size of Ether.js library is much less as compared to Web3.js library. So if you will see all the points here, all the points are in support of Ether.js, and definitely if you will see all the points, Ether.js is actually winning over Web3.js library. But am I suggesting you to just learn Ether.js library and not go to Web3.js library? So the answer is a big no. You should learn Web3.js library because Web3.js library was the first library, right, which actually helped us in connecting with the blockchain. So I will never suggest you to not to learn Web3.js library. You must learn Web3.js library and then you should go to Ether.js library because a lot of projects are also still using Web3.js library and they are looking for developers who know Web3.js library. So definitely you should learn Ether.js library, but you should also learn the fundamentals, at least the fundamentals of Web3.js library so that you know how to create a simple decentralized application using Web3.js library. So congratulations for completing this course. I hope you enjoyed this particular course, and if you have enjoyed this particular course, please click on that like button, and if you are new to this channel, please subscribe to this particular channel because I'm regularly going to upload new blockchain courses on this channel. And if you want to connect with me on Instagram or LinkedIn, these are the IDs. You can connect with me. If you have any doubts, you can message me there as well. And if you have any doubts regarding this particular course or anything, you can comment below this video as well. So thank you so much guys. Meet you soon in the next video. Take care. Bye bye.